Well, golly gee whiz, I looked on my bench and surprise, surprise, another Seeburg. Yes, the owner of the SHP3 that was recently completed was very excited, very happy about the sound coming out of his amplifier. As a matter of fact, he's quite a lot of hyperbole in a positive manner to describe how happy he was with it. So, he was so happy to show his gratitude, he that SOB gave me another one. So, this one is having a couple of problems, and the reason that he had kind of, let's say, cut it out of the herd in the first place was because it was having a problem with the mute trip relay. So the mute trip relay is essentially there to keep those big loud noises off of your speaker, so that when the record actually begins to put out some sound, when that needle drops onto the album, it's going to send a large pulse of voltage to the system. So the amplifier is muted during this, and that's exactly what this mute trip relay right here does. And it's not a very complicated circuit, so there probably shouldn't be too much wrong here. And a lot of times it's just dirty contacts on the relay. So the other thing is that somehow I guess this got a little dropped, and the capacitor on this side, the phenol gasket, which looks a lot like one of these, is broken. So we're going to need to replace that too. And I've got this older one here, and it's just fine. We'll just have to clean it back up, and those will actually come off. Here's another one that I also have, and this one's looks like somebody's already tried to drill through the old rivets. So, and that's what I'll have to do here. These are the original capacitors, more than likely, and they have still the rivets right through the chassis. So, and according to him, these capacitors are good. He's not interested in changing them. I did run a little power through the amplifier, and it does play. Having said that, the mute trip is not working. So when we first power this up, we should hear a click from this relay, and you should be able to hear it over the camera. So I'm going to go ahead and flip the on switch right now, and you heard our speakers just, well, why? Well, our mute trip relay didn't kick in. We did not get a click. So I'm going to go ahead and pull this out, and we're going to take a quick look at it and see if we have a bad mute trip relay. Now, it could just be a bad relay. It also could have dirty contacts, and see if I can get this apart and show you what's going on. Let me set up the next shot, and I'll show you. Okay, so once again, little disclaimer: if you're not comfortable working around electricity, please leave this up to a professional. You should always use the proper safety measurements, such as current limiting and isolation transformers. And if you don't know what any of that means, you should probably do a little research on that before you try and monkey around with any of this equipment. It can be very dangerous to you and those around you. So you're doing this at your own accord. Please don't mimic the monkey. Okay, so what we have here is our relay, and we'll see if we can kind of get this into shot. If we need a little refresher course on how a relay works, I should be able to see. So you can get some better light on this, possibly, maybe. Our relays are a series of contacts. Well, essentially, we have a series of contacts on either side here. You can see that they correspond to pins directly. So if we were to, just for grins and giggles, take our multimeter and go directly from this pin through to this pin, you would see we have continuity on the pins, and that's there's not a lot of resistance there at all. But if we were to go to this pin, clearly, well, I'm touching the probe across two pins, so let's do this way. If we were to go to this bottom pin right here, you'll notice we have no continuity, and that's what we shouldn't have any, because right now the contacts are closed on this side. So if we look at this like one wire, okay, and we go back up to this top pin, there's a little hole right here. There we go. And we just look at this as one wire with the contact closed. Notice we we have continuity again. So, well, we should have continuity. It's going to make a liar out of me. And there we go. So this is almost acting like a wire. But the way that this would work is we have a coil, and this coil is actually powering a magnet. So when we energize this coil, it's going to turn on the magnet, and the magnet is going to pull down on this metal plate, which is spring-loaded right across here. So as this plate gets pulled down, it will close the contacts at this point, thus making contact on these pins. So it's acting as a switch. It's effectively acting as a two-position switch. So when we have power to the coil, the switch closes to the other direction. When we release the power, the spring causes the pins to contacts to close on the other side. So effectively, this is a two-position relay switch, but we've got 4 different gangs we can control here. So that's kind of nice. So how do we know that this coil is working? How do we test this? Well, the first thing we can do is we can kind of follow the wiring, and we can see possibly there's a small wire that runs from this pin right up into our coil. And if we go to the other side, we can see there's another right that goes in there. So now most diode meters, a lot of them will only, if you put your meter in continuity or in diode mode, let's say like right here. Now if we touch the pins together, we're going to get continuity. But a lot of these won't really give you the beep anything over 50 ohms. So if we touch our pins here, we probably won't get a beep. We won't. It's still showing an open load. But if I turn this thing back into ohms mode, and we do the same thing, well, we got about 635 ohms. It's actually in the kilo ohms range, but you notice it's a 0.635. So it's about 635 ohms. And you know what? For a big coil of wire, I mean, that's a lot of wire that's wrapped around that. That's probably about right. So we do have continuity, and we have resistance, but it's a fairly low amount of resistance if you think all the wire that has to go through. So at this point, we would just want to check the connections between all of these points across the bottom, because our switch wires come right here. So if we just went right across here, you see we have continuity, and then we could move over to the next set of pins and so on and so forth. So as long as everything has continuity on it, we probably have a good switch, but we may have some dirty contacts. So we could clean those sorry, I keep getting out of frame. We could clean those contacts, but my guess is that this is probably a good relay. Usually the contacts, the coil will still operate, just you won't get any sound, or you'll get scratching, popping, nasty stuff. So let's go ahead and see. Well, how can we test this coil? Well, we'll do the same thing that the amplifier would do, which is put a little power through it, right? So let me get that set up and I'll show you. Okay, so I've had to move some things around here, and basically what I've done is I've just taken my DC power supply, and we've just put some limited current but some voltage through this thing, and we should be able to hear this relay click if it's working. I've got my coil terminals connected on one side. I'm going to go ahead and complete the circuit, and we should hear a click. Hear that? There you go. So it's working. Let's flip this over and we can see the coil action. Again, I'm a trained professional. I stayed at a Holiday Inn Express last week. Okay, it was last month. See if we can keep a real close eye on our coil. There we go. So our relay is functioning. So my guess is at this point that while this is the common culprit, it's not our culprit today. So we can go ahead and clean this up, and the way that we clean it up is we put a little deoxit on a very thin strip of paper, and you just drag the piece of paper right through those contacts very carefully and make sure that you don't break anything. So once we've tested for continuity and cleaned this up, we can just set it off to the side, and we'll go ahead and continue to troubleshoot. So I will set up the next shot, and we will continue from there. As a matter of fact, we might just go ahead and break out the schematic at this point and take a look at this mute trip relay. Okay, so right now we are looking at our schematics, and we know a couple of things. Number one, we know our relay is working if we pull it out of circuit, so that means that whatever is affecting it is probably happening in circuit. I have taken the liberty of measuring for voltage at our mute trip relay. We do have voltage where it's supposed to have voltage, but it's not closing. So why isn't it? Well, there's not a whole lot going on in this trip relay. It's got a diode right across the relay right here. Here's our relay. These are all the contacts in order with it. We have it going to some pin connections on a socket, and then we have it going to this mechanism. The J5103 is for the ABC disable, the trip solenoid. We've got a couple of no connections, and then a ground. So we could have something going on up in this end, or we could have something going on right here. It says diode. Now I'm gonna want to check this diode. I'm not gonna make any bets right now, but I'm gonna want to check this diode, because if that diode isn't dioding, then it's there for a reason, and the mute trip relay may not be functioning correctly. So that's definitely something that we need to check. If we follow our node over here, continue to follow our trace. Remember, in this schematic, we don't have any passovers. If there's a node, there's a contact, a little dot, there's a contact. If it just goes straight over, that means there's no contact. So if we follow this up, we will go to our pin 10, which is reject. Now, one of the things that I did before, this is actually the volume control cable. Yeah, you can't see that, can you? Hang on, let's get that into. You can almost see it, not quite though. So right here, where my pin is at, this would be pin 10. It would be the second pin over, and this is for a socket, and that socket is connected to the volume control cable. So you have all of our volume control go to me, come from me wires, and we have the reject button and also audio ground. So you can lose audio signal because you lose this ground point right here, and you can no longer control the volume or anything. It just becomes dead. So I know that the cable that I have has a problem with the volume, which is going to be addressed. I just haven't gotten around to it. We just found that out during the last video. So, but it didn't have any problem with the reject at all, and it still doesn't. So I'm going to assume that when I press the reject button and we didn't get a response from the relay, that means that we're kind of narrowing down the field, most likely. Most likely at this point, it's going to have something to do with this diode. Now, this resistor value could obviously change our voltage on our negative 32 volt rail, but I did put the meter to the rails before I put any power through, well, before I put any signal through it, and our rail voltage was pretty close, negative 32 volts on one side and positive 32 volts on the other. Well, it's about 31.08 on either side, so it's pretty close. So that kind of limits it to this diode, or maybe something up in this, this mechanism. But here's the thing: this mechanism does not need to be plugged in order for this amplifier to work. So I doubt that that is the problem. Now, you may have to jump the mute trip relay to ground in order to get this thing closed in the first place, so that you can actually get sound through it. And I've had that happen. It just happened to me the other morning a couple times. I didn't realize it. But for the most part, it's kind of zeroing in on this diode right here. So when we flip this chassis over, there are no visible diodes other than in the rectifier section. It's the only place you're going to find a diode that's not on the circuit board, other than some up in the signal chain, which are under the heatsink, so you shouldn't see those anyway. So the diode that we're looking for is a pretty small diode. I've seen it on the other amplifiers. I know exactly where it's at, so it won't take me long to get there. But you might have a little problem seeing it depending on how much wire they've buried it under. Other than that diode, there are only two resistors. This 180 ohm resistor right here, and I'm not sure, we probably can't see that down here in the power supply section. we have that 330 ohm resistor. So there's not really a lot that looks like a resistor or a diode in the chassis, but even at that, if this is the one, I'm pretty sure it is, because it'll be connected to right where this node connects right to this 180 ohm resistor. So if you can see the 180 ohm resistor, then you're not that far from your diode. So let me go ahead and dig around, and we'll test that with the meter and see where we're at. Okay, I found our diode. Do you see it? Yeah, I didn't see it at first either, but I do know that it's connected to this resistor somewhere. And this resistor has been changed. These are not the original resistors. Somebody has definitely doubled up a couple of resistors to come up with a value, so we'll have to check that. But we also have this is the other resistor, and if you go again, right off of our no power in this, by the way, our rectifier section, we've got our big old 330 ohm resistor right there. So if we drop this board, this is the driver board. If we go ahead and drop this carefully. These things are old and brittle, these little standoffs. And they're really cool. They work well, but they are not that difficult to break. I did break one once. So go ahead and gently pull this out and kind of let it drop. This tripod's going to actually be in the way right there. And if we move our wiring section over just a little bit, let's see if I can get this. It might be better to go the other way with this one. Oh, see our leg? Probably not, because I'm looking right at it and I can barely see it. But hiding right underneath here is our diode, way down there between my fenders. So let me grab my meter, we'll put it in diode mode. See if we have a good or bad diode. Sorry about the shaky cam. This is very tedious trying to move things around while you're not sure if you'll be able to see that or not. And which way are we facing here? Oh, okay, so we should. Uh-oh. That is a shorted diode. I think we just found our problem. So either there is a short across the diode, or there's a short somewhere else right around there that's causing our continuity to go closed under 50 ohms, which is indicating a short. So my guess is it's probably going to be the diode. So I will go ahead and pull that out of circuit. We'll take a look at that diode, and then I'll see if I have another one. We may have to pause this for a few days to get another diode. I'm not sure. So just stand by. Let not your heart be troubled. We will be right back. Okay, it's actually been a minute since I filmed anything, and the reason why is because when I went to take the old diode out, which you can see there's our new diode that's already been soldered in place. Yeah, the old diode just kind of gave up the ghost. Said, yeah, done. I'm out. It was already kind of deceased. It's a frail, brittle little corpse, just kind of broke in half. So barely touched it and she popped. So having said that, we now have our new diode, at least a suitable diode for now, placed in circuit. And also, while I was doing this, I noticed that this pin right here and the connections on it were just nasty. There were pieces of busted, nasty, burnt wire that just didn't look like there was any possible way it could be making a good connection. So we replaced that. Well, we trimmed our wires back. This is our ground wire, one of our ground wires. Another ground wire, obviously this whole pin set right here. But this actually goes up to our socket that the mute trip relay plugs into. So, wonder what the problem could be, right? So replacing this, we actually have a little jumper right here between these two pins that's supposed to be there. This would be our transformer ground wire. So moving over to this pin, we have a ground that goes right to socket. You see all these suspect things like right in a row. So now if we turn on our power, and we jump our pin set. I don't pull the pin out. Listen very carefully, and any second now. Let's move this around just a little bit. See what we're doing, so I can see what I'm doing. Hear that? See if I can get the camera a little closer. So there's our relay. Our relay is working. So we still have a problem with the reject switch, and right now, just based on what I'm seeing, I'm going to pull this back again. Just based on what I'm seeing, I'm pretty sure that it is up in this. Apologies for the shaky cam. I believe our problem is probably right up in this socket area, because this is where our volume socket plugs in. So my guess is if I take this apart, which I'm not going to do in this video just because it's a little time consuming, we'll find the rest of the problem. But for the most part, we needed to get the mute trip relay working or replaced, and obviously replacing it wouldn't have done it in this video. So so 90% of the battle is done. We just need to figure out what's going on up in that volume, and that's going to be it. So I guess if we're having a problem with our mute trip trip relay, you can kind of use this video as a guideline. You know, I mean, grab the schematics if you can, follow the wires yourself, make the connections. You'll get there. It's there's not really much to that. So all right, I'm gonna go ahead and end this video. I think next time we're gonna do a not Seeburg. I said that before, but I think I was not correct. So at this point, I think we've done enough Seeburg for a little while. I think maybe we'll get into we have another. Well, let's see. We have an AMI control board here. We might get into that. I think we also have a projector somebody dropped off that needs to be looked at. Apparently, it's pulling current. There's a couple of things. Not just. Yeah, we got more than that. So I'll get something picked out, and we'll make an interesting video. So, okay, we're gonna go ahead and end it with that. I hope you learned something. I think I did. And I'll see you in the next video. Thanks for watching.